conference will now be recorded.
Now, this is the first question was asked in the GATE 2004. Misran is a casting defect which occurs due to there are the four options. The first option is very high pouring temperature of the metal. Second is the insufficient fluidity of molten metal. And the C option will be the absorption of gases by the liquid metal. And the D option is improper alignment of the molding press. So first of all, you understood what is the Misran. Misran is basically a casting defect only. What happens? Let us suppose, so Misran is basically a casting defect. Let us suppose if you are doing the casting of the L-shaped cavity, or we can say that the C kind of cavity, if you are pouring the liquid molten metal into this cavity, so before reaching to the end section, it will solidify. It will solidify here only. It will solidify before reaching to the end section. That is called as a Misran. Okay. So one more defect which is related to this one, that is called as a cold shut. This is called as a Misran, and this is because of the insufficient fluidity of molten metal. If the molten metal is not able to flow easily and not able to reach the end section, this kind of defect has been observed. The second defect, which is called as a cold shut. What is cold shut? So let us suppose the two stream of liquid, they are coming from, one is coming from this end, another is coming from this end, and they will not properly fuse together. That means before fusing, they will solidify here. They will solidify here. That means these two stream of the liquid will not make a contact, and then there is a defect that is called as a cold shut. That is called as a cold shut. And both the type of defect is basically because of the insufficient fluidity of the molten metal. The liquid molten metal which you are using to fill this mold cavity, they are not able to easily flow at the end section. So the correct answer for this question is the B. So choice B will be the answer. Now, the next question is, this question was asked in the GATE 2005. What is the question? A mold has a down screw whose length is 20 centimeter. The cross-sectional area at the base of down screw is 1 centimeter square. The down screw feeds horizontal runner leading into the mold cavity of volume is given as 1000 centimeter cube. Okay. You have to calculate how much time is required to fill the mold cavity. Okay. So first of all, this question is related to the top gating system. What is happening actually? Now see, this is basically a screw. And this will be the runner. And this is the mold cavity. Okay. So the down screw whose length is given as 20 centimeter. 20 centimeter. Now you are pouring the liquid molten metal here, and you want to fill this particular mold cavity. Okay. The volume of mold cavity is already given, which is 1000 centimeter cube. The volume is given as 1000 centimeter cube. You have to calculate how much time is required to fill the mold cavity. And the area at the base of the down screw is also given. That means the area at the gate, which is given as 1 centimeter square. So what is the time required to filling the mold cavity? The volume of mold divided by AG, that is the area at the gate, times of 2G into ht. Okay. Now you can see here, this is the area and this is the velocity. What is the product of area and velocity? That is the discharge, or we can say that it is a Q only. And if you divide this volume with time, then again you will get the volume flow rate. Okay, so if you equate the volume flow rate, then you will get this particular formula. So volume flow rate means the V dot can be written as V by T is equal to area into velocity. By using the continuity equation also, you know. So area into velocity is the discharge. So what is the data given? Volume of mold is given as 1000 centimeter cube. Okay. So you can convert into the meter. So it will become 10 to the power of -6. AG value is, what is the area at the gate? 1 into 10 to the power of -4 and root 2 G. So here G is not mentioned. So you have to consider 9.81. So suppose if in the question it is mentioned that the value of G is 10 meter per second square, then you have to consider that value. Okay. If it is not mentioned, then you have to consider the 9.81. So what is the height? The height of this is given as 20. If you want to convert, you can convert into the meter, because I am just converting all the data in the meter only. Okay. So now the time required for filling the mold cavity, once you will calculate, please try to solve and tell me what answer you are getting. Anyone got the answer? So once you will solve, then you will get 5.05 second. Okay. So that means the total time which is required to fill the mold cavity is nothing but 5.05. So what is the correct answer for this question? Please be. Now, so in case of manufacturing, if I will talk about the casting point of view, the question can be framed based on the design of riser, and the question based on the how you will calculate the time which is required for filling the mold cavity, and question related to the defect. Okay, so I have discussed the defect question, and this is the time required of filling the mold cavity. Now the next question, if you see, this question is related to the gating system only, in which you have to find the relation between how much time is required for filling the mold cavity by bottom gate system and the top gate system. Okay, but there is a special condition for this, very important. If you know that particular formula, if you apply those special condition, then you will get the answer. Okay, so we have to find out of these four options which one will be the correct. So what is the question? In a sand casting process or sand casting operation, the total liquid head is maintained constant such that it is equal to the mold height. Okay, so it is given that the total height is equal to the mold height. This is the important condition. This is the important condition. The time taken to fill the mold with a top gate system,
Really,
if you are, yeah, tell me,
sir, whatever you're explaining, I can't see it on the screen.
can you repeat once again?
Sure, sir. Sir, whatever you are speaking and whatever you're explaining, I can't see it on the screen, sir. I mean the slides, sir. Presentation slides.
Okay, just 1 second. Uh, can you refresh from your side? I think it is visible, because if I'm moving the screen, one thing you
Okay,
do,
sir,
you
I'll
join
make this.
again. Okay, you just
Okay.
end and again you join this session.
Hmm.
I'm just waiting for you.
Yeah, sure, sir.
Yeah, Raj, now I think it's visible. Is it fine, Raj?
Yes, sir.
Now is it okay?
Yeah, now it is okay, sir.
Okay. So the question is, if the same mold is filling with the bottom gate system, and one more thing, whatever the session I'm taking, it is in the recorded mode. Even if you miss something, then you can see again. Okay, there is no issue. So if the same mold is filled with the bottom gate system, the time taken is TB,
Okay.
ignoring the time required to fill the runner and the frictional effect. You have to find out the relation between TA and TB. Okay. So you know that the time required for filling the mold cavity by bottom gate system, what is the time required for filling the mold cavity, which is 2a. Even I have discussed this in my live classes also. Root 2g ht minus hm. Okay. So here ht is basically is the total height and hm will be the mold height. So it is given that the total liquid head is maintained constant such that it is equal to the mold height. That means ht value is equal to hm. Okay. So the ht value is equal to hm. So this time is basically represented with the TB. It is given that the time required to fill the mold cavity by bottom gate system is TB. Now you have to find out what is the relation between TB and TA. TA is basically the time required to fill the mold cavity by the top gate system. Okay. Now, if HT
Is
is
this
equal to HM, can I write? Yeah, Raj, tell me.
sir, due to network issue, just now I have missed what you have spoken, sir. So can you repeat once again quickly what you have told just now 10 seconds before?
The bottom gate system, the total time required to filling the mold cavity is TB. So 2A divided by AG root 2G. That means the TB I am denoting with the how much time is required to fill the mold cavity by bottom gate system. Okay, this is mentioned in the question. And TA is the time required to fill the mold cavity by the top gate system. So you have to find out the relation between the time required to fill the mold cavity by the top gate system as well as the bottom gate system. Okay. Now, if you take HT is equal to HM, then what is this formula? So 2A AG root 2G. So HT is equal to HM means this will become 0. So this will become HM. So you can put as either as a HT or HM because both are same. If suppose if I will multiply with root of HM in both denominator and the numerator, so what you will get? Here it is also HM. So this HM root HM will become HM AG, and you know that this HM value is equal to HT. HM value is equal to H2, and this is the standard result. But how this result came, that I'm going to discuss. So HM is equal to HT means now you can see here A is the area of the mold cavity and HM is the height of mold cavity. So what is the total? This is the volume of mold cavity. Yes or no? So AG root 2G HT is the total time required to fill the mold cavity by bottom gate system. And now you know that V by AG by root 2 GST. Just now I have discussed one problem. You can see here also. VM by AG root 2 GST is nothing but the time required to fill the mold cavity by top gate system. So that means the TB can be written as 2 times of TA. TB can be written as 2 times of TA. So which option will be the correct? So the B is the correct answer. B is the correct answer for this question. Okay. Now, this question is very important. And one more thing, they can frame this same type of problem in the numerical form. Okay, they will give you the data, like for example, the total time required for filling the mold cavity by top gate system will be 2 minutes. Then what will be the total time required for filling the mold cavity by bottom gate system? So the correct answer will be 4 minutes. The only condition is if the total height, this total height will be equal to the height of mold cavity. Okay. Now the next thing, so I'm not giving you the time for making the notes because you will definitely get this recorded session. You can uh, watch again. Now the next question is, first you read this question, then I will explain. Okay. Now see, the volume of cube of side L and the volume of sphere of radius R are equal. Okay, it is given that the volume of cube and the volume of sphere is equal. Both the cube and sphere are solid and are made up of same material. They are being casted. Okay, you are doing the casting of two different types of uh, geometry. The first one is the cube and another will be the sphere. They are being casted. The ratio of solidification time of cube to the solidification time of sphere you have to calculate. Very simple question. It is based on the solidification time formula. Now you know that the solidification time is equal to K into V by A whole square. What is this K? K is called as the solidification time constant. V is the volume. A is the surface area. A is the surface area. Okay. Now, if you read the question, the volume of the sphere is equal to volume of cube. It is given. Now you can see here, volume of cube of side L is equal to volume of sphere are equal. Now, what is the for cube? Can I write the solidification time for cube? I'm denoting with cube with a C subscript and K. This is the volume of the sphere divided by area of sphere whole square. Similarly, for sphere, the solidification time of the sphere is equal to K into V by A. Here I can mention as a C because this is for the solidification time of cube. Now for sphere, it will be Vs and As. Okay. Now if you divide this first and second equation, then you will get the ratio of the solidification time. But you have to calculate the ratio of solidification time of cube to the sphere. Okay, no problem. So if you divide the first and second, solidification time of cube, solidification time of sphere, okay, this kk will cancel out and the volume of cube and the volume of sphere are equal. Okay, that means only the area is left. So can I write this is as divided by AC whole square? As divided by AC whole square. Is it clear, Raj? This one is clear. The k will cancel out, the volume is equal.
Yes, sir.
Okay. Now, if As by AC, you have to calculate what is the surface area of a sphere. Surface area of a sphere is nothing but 4 pi r square. And what is the surface area of cube? 6a square. 6a square. Now, You just put this thing in this as by ac. This is r square divided by 6a square, and this is whole square. Okay. So what are the options? 4 pi by 6 r by l. Now the answer will be 4 pi by 6 whole square r by a, or here it is mentioned as a, instead of a they have taken as a l is the side of q, no problem. So I will mention in the same notation, this will become l. So r by l whole square. So the solidification time of cube to the solidification time of sphere is coming out to be 4 pi by 6 whole square into r by l whole square. So what is the r by l whole square to the power of square? Because this is r square by l square, or you can write in the r by l to the power of 4. So the correct answer for this question is D. So the D will be the correct answer. Okay. Now, the same type of question they can frame. They can give you the volume, or we can say that they will give you the dimension of sphere. That means the radius of sphere and the side of the cube. Then you can easily calculate the ratio of solidification time of cube and solidification time of sphere. Okay. But the concept is same only. If you have thorough understanding of concept, numerical value they will give, then you just put on the formula, you will get the answer. Okay. Now, one beautiful problem. This question was asked in the GATE 2007. I will make as a star mark. Now, first you read the question and try to solve. Otherwise, I will explain. Okay. Read the question carefully and try to find out the important data. No need to make notes because this is already in the recorded mode. You can see later on also. Yeah, Raj, it is given, no? The volume of cube of side L and volume of radius are equal. That's why I have taken. Understood?
Okay, sir.
Please read this question. Okay. I hope you already read this question. Now, a 200 long down screw has an area of cross section is 650 millimeter square. Okay, where the pouring basin meets the down screw. Okay, this is the figure given in the question. This is the pouring basin from which the liquid molten metal is entering into the screw, and from the screw it will enter into the mold cavity. Okay, the height of screw, which is given as a 200 and the area here it is given as a 650 millimeter square. Area of the down screw you have to calculate. So a constant head of molten metal is maintained by the pouring basin. Molten metal flow rate. Okay, so the flow rate is given. That let us suppose the flow rate I am denoting with Q, 6.5 into 10 to the power of 5 millimeter cube per second. Now, considering the effect of down screw to be open to atmosphere and at acceleration due to gravity. Okay, that's why I told you if nothing is mentioned, you have to consider 9.81. But here it is clearly mentioned the acceleration due to gravity is 10 meter per second square, or we can say that 10 to the power of 4 millimeter per second square. So again, I'm considering G value is 10 to the power of 4 millimeter per second square. So it is mentioned to avoid the air aspiration effect. So first of all, you understood what do you mean by the air aspiration effect or aspiration effect. What is happening actually when you are pouring the liquid molten metal through the pouring basin into the sprue, if you are making the sprue like this, then what will happen? The air will get trapped because the pressure at this point will be negative. That's why we are making the sprue in the form of tapered section. Now let us suppose if I'm assuming this is the point 1, this is the point 2, and this will be the point 3. Okay. Now the area which is A2 is given as 650 millimeter square, and height is given as, let us suppose H2 height of the screw is 200 mm. Now the flow rate which is given as 6.5 into 10 to the power of 5. Let me check. Yeah, millimeter cube per second. So you know that what is the flow rate? A2 into V2 is equal to Q. Can I write? This is basically the area and this is the velocity. So I'm denoting with a small letter V. A2 V2 is equal to the flow rate only. Now from here you can easily calculate the V2 value. V2 value 6.5 into 10 to the power of 5 divided by what is the value of A2? 650. Then if you solve, then you will get 1000 millimeter per second. Okay, now you got the velocity at 2 point. So you know that the flow rate will be constant. There is no fluid or the no molten metal is coming out from the this point because there is no hole. That means whatever the flow rate is here, the same flow rate will be here. So can I write this Q can be written as A2 V2 is equal to A3 V2? Yes, of course I can write. So A2 V2, that is the Q value I know already. If somehow if I will find the velocity at 3 points, your problem will be solved. Are you understanding how you will approach in the problem? If you calculate the V3 value, your problem is solved because you have to calculate what is the area of down screw at the end. That means at this point, what is the area? For that, you have to apply the Bernoulli equation. What is the Bernoulli equation? I think you have read in the fluid mechanics also. Bernoulli equation, I will apply between 2 and 3. 2 and 3. Why? Because the velocity at 2 point I know, and the velocity at 3 point I have to calculate. Okay, so what is the Bernoulli equation? So V2 square by 2G. So this is the total height is H, which is equal to V3 square by 2G. The pressure at this point is it is open to atmosphere. So in the gauge, it will be 0. So the pressure will be constant only. It is also given. What is the aspiration effect? To avoid the aspiration effect, you have to maintain the pressure throughout the screw will be constant. That means the pressure at P2 and pressure at P3 should be constant. So P2 by rho g and P3 by rho g, they are cancel out. V2 square by 2g is the kinetic head and this is the datum head, H. Okay, so I'm measuring from this distance. So H3 value is 0. So from here, this I'm denoting with the H, or I can represent as a H2. Now you know already the V2 value, that is 1000 square divided by 2 into G. What is the G value? G value is 10 to the power of 4 plus H2 value 200 mm. V3 square by 2G. V3 square by 2G. Now if you solve this V3 value, you will get 2236.068 meter per second. Sorry, not meter, it's a millimeter per second. Okay. Now, if you know the V3 value, then your problem is solved. The Q value is 6.5 into 10 to the power of 5 divided by what is the V3 value? 2236.068 is equal to A3. Then A3 value, let me check this value, what the value is coming. The value is 6.5 into 10 to the power of 5 divided by 2236.068. So this value is 290.68. 290.68. This is the area which will be in the millimeter square. Which will be in the millimeter square. So what is the correct answer for this question? The correct answer for this question is 290.7. The most important thing is to understand what do you mean by aspiration effect. Aspiration effect means the pressure throughout the screw should be constant. To maintaining the constant, that's why we are making as a tapered screw. Tapered screw. So the area value you are getting as a 290.68. The choice. Let me check what is the option. Yeah. Choice C will be the correct answer.
Sir,
Yeah. Tell me.
sir, here you have written this Bernoulli's equation. So, if in any question of
Raj,
manufacturing,
can you speak loudly? I'm not able to hear you, or otherwise you can text in the chat box.
okay, sir, now we'll speak loudly. Sir, the thing is, sir, you have given here this Bernoulli equation for this question, sir. So, sir, if in any question, if they'll ask about aspiration effect by, as asked in this question, if anywhere if they'll mention aspiration effect, I need to use this Bernoulli
Hmm.
equation.
Correct. Yeah, yeah. Aspiration effect. No, no. You have to calculate the velocity at some point. Okay. The aspiration effect means if suppose you can make the screw in this form also, no? You can make the screw in this form also. So if you are using as a straight section, what is happening? The pressure at the 2 point is the negative one. Then what will happen if there is a pressure at this point is negative? So all the atmospheric gases through this sand mold will trap. And because of this, there will be a gas defect. That's why we are making the shape of this screw as a tapered one. Now, why we use the Bernoulli equation? Because at one point you know the velocity. Okay. For other point, if you want to calculate some unknown parameter, so you have to use the Bernoulli equation, no? Because the molten liquid metal is flowing. Understood?
Sir, here I have to use Bernoulli's equation. Means that the thing is,
Raj, your voice
okay,
is disturbing. I'm not able to hear you. Either you can chat, mention your query in the chat box, or you speak loudly.
okay, sir. So what I have, okay, sir. If in any question they will ask about aspiration effect, like avoiding aspiration effect or neglecting or considering aspiration effect. If they'll mention considering aspiration effect, I have to calculate this cross sectional area and then I have to use this Bernoulli's equation.
Correct. Then you have to use the Bernoulli equation to get the unknown velocity. Okay. Because the point 2 and point 3, which are connected through the Bernoulli only, no? How you will calculate otherwise velocity? Because you know only the discharge at 2 and 3 point, but one parameter is unknown. Area is also unknown, velocity is also unknown. The area at the 3 and the area velocity at the 3 is also unknown. So you want to calculate the area. So to get the velocity value, you have to use the Bernoulli equation. I think you have solved these kind of problems in fluid mechanics also. Understood? Even if you have a doubt, please let me know. Otherwise, I
Okay,
will
sir.
move to the
Here I
next
have to
question.
use okay, sir. Here I have to use Bernoulli equation for knowing the unknown velocity or the velocity of the flowing material, which is the molten metal here.
Yes, the velocity at the 3. Once you know the velocity discharge value, you also know. Then you can easily calculate. Then
Means that if I know discharge velocity, I can calculate this final velocity.
Yeah, this is very simple, no? The discharge is equal to A2 into V2, A3 is V3. Because whatever the liquid molten metal is coming from here, it will go down, no? There is no hole. If there is another hole here, then discharge can be divided into Q1 and Q2, I can say that.
Okay, sir.
Yeah. Now, the next question is, which is also related to the two streams of liquid molten metal, which are not enough to fuse properly, resulting into the casting defect. Okay, so you have to tell me, because I have already discussed the same concept in the first question. In that question, the miscellaneous is a kind of defect I have discussed, but I have given you some insight of other defect also. When the two stream of liquid metal are not fusing properly, what is the defect for?
Um, One more thing, sir. Here, as we have discussed in the recent question, the previous question, when I, as, when aspiration effect is given, sir, I have to calculate area of cross section. Here, I have to calculate the third at the point remains at the final
No,
point.
I'm not asking the numerical question. The first question I'm telling you, two stream of liquid metal which are not fused to properly. I have discussed, no, this casting defect. This question I was talking about. See, Mizran is a casting defect which occurs due to there are the four options because of the insufficient fluidity. Okay, this question was asked in the GATE 2004, but I have given you the other information about the cold shut because both are due to the insufficient fluidity only. But what is the basic difference between Mizran and cold shut? When liquid molten metal will not enter to the one end only, then it is called as a Mizran. What do you mean by cold shut? When the two stream of fluid is coming and they are not fusing properly. Okay, before reaching to here, it will solidify because of the insufficient fluidity. The liquid molten metal which you are using, it doesn't have good fluidity. That is called as a cold shut. And the same type of problem was asked in the GATE 2006. That's why I have taken in the later stage so that you can appreciate why these note points which I used in the classes are important. This question was asked in GATE 2009, sorry, not 2006. Two stream of liquid metal which are not hot enough to fuse properly. So what is the correct answer? When the two stream of liquid molten metal, they are not fusing properly. That means these are the two stream of fluid. One is coming from here, one is coming from here. They are not fusing properly. Then they will result a defect which is called as a collision. This I have discussed, yes or no? The first question itself I have discussed this. So GATE 2004 they have asked about the measurement. Then in the next, which is related to the insufficient fluidity only, they have framed one more question. The correct answer for this question is choice A. Choice A will be the correct answer. Now, one more question. While cooling a cubical casting of size 40 mm, okay, so let us suppose one cubical casting is there of 40 mm undergoes 3%, 4%, and 5% volume shrinkage. During the liquid state, phase transition, and the solid state, the volume of metal compensated by riser. Okay, so you have to calculate how much volume will be compensated from the riser. Very simple, no need to solve this. If you know the concept, you can easily identify which one will be correct. I think this question I have discussed in live classes also. Can you tell me which one will be the correct answer? Otherwise, I will explain. You got,
Certainly,
Raj?
sir, I didn't get this question, sir. Here, I can't solve as here with involvement of three stages. Sir. Uh,
Can you tell me which answer will be the correct? Okay, so let me explain again. I think you are not revising whatever I have discussed earlier.
Sir, maybe I didn't done this question, but maybe I have done a question similar to this, somewhat a little bit similar to this. Excuse me, sir. I am unable to hear what you are speaking.
Yeah. So what do you do in the casting basically? You will pour the liquid molten metal into the mold cavity. Okay. Once it will solidify, then the product can be taken out. Okay. So this is the point which is called as a pouring temperature. Pouring temperature is the temperature at which the liquid molten metal is entering. Now, then there will be a temperature drop from pouring temperature to the melting temperature. This is called as a melting temperature. Usually the pouring temperature will be higher than the melting temperature. Melting temperature means, for example, let us suppose for iron, the melting temperature is, I'm just taking example, 1500. So you have to take the pouring temperature will be 1700 or 1800 so that the liquid molten metal can easily flow into the mold cavity. Now, this pouring temperature, as I think now it's visible because some internet issue in between that hearing has stopped. Okay, now what I was discussing, if you are doing casting operation, so this is basically the pouring temperature and this is the melting temperature. Now, this melting temperature means the liquid, this molten metal will be at the liquid state. Then there will be a phase transformation. Because you know that once you are pouring the liquid molten metal, once it will solidify, then you will break the mold and you will get the casting. Now, this portion is called as a release of heat because of, that is called as a degree of superheat. Degree of superheat. That means you have heated this molten liquid metal above this melting temperature to the pouring temperature. Okay. So this is basically the phase transformation. The second type of shrinkage. There are the three type of shrinkage. In this case, the first shrinkage is called as a liquid shrinkage, and this shrinkage is called as a solidification shrinkage. Because you know that the solidification means it will be happening at the same temperature. Now there will be a solid shrinkage. Solid shrinkage. So from this melting temperature to the room temperature, this is called as the room temperature, which is denoted with T0. Now, The first two type of shrinkage, which is called as a, so if I will write the first two shrinkage, that is nothing but liquid plus solidification. Liquid plus solidification, that means these two shrinkage I am talking about. That can be compensated or compensate by providing riser. A riser is nothing but it is basically a reservoir of liquid molten metal. Okay, because you know that I have already discussed these are the gating element. This is pouring basin, the sprue, and there is a runner. This is the mold cavity, and at the top of here there will be a riser. The riser will supply the liquid molten metal during the solidification. Okay, whenever the extra material is required, it will supply that one. So these two type of shrinkage, the first two shrinkage, liquid and solidification, is compensated by providing riser. That means it can be done by the riser only, riser volume. But the third type of shrinkage, which is the solid shrinkage, can be compensated by providing allowance on the material, pattern. Okay, because you know that for making a mold cavity, you need a, suppose if you are making a mold cavity and if you want to make a product, so pattern, you are using a pattern which is the replica of design product, whatever the product you want to manufacture. So because during the shrinkage, the liquid molten metal, during the shrinkage of the liquid molten metal, what will happen? The size will get reduced. For example, if you want to make a cube of size is 30 mm, during the shrinkage, once it will undergo the shrinkage, the size value will be reduced from 28 to, let us suppose, 29.2. So that's why you are making a pattern of larger size, so that after the shrinkage, it will reach to the original one, whatever you want, or the desired one. So these third type of shrinkage, which is solid shrinkage, that can be compensated by providing the allowances. And where you are providing the allowances? On the pattern. Now, if you read the question, then you will get to know, while cooling, that means you are doing the cooling, that means you are decreasing the temperature. A cubical casting of side 40 mm undergoes 3% shrinkage, 4% shrinkage, and 5% volume shrinkage, which will be occurring in the liquid state. That means this is the liquid state. Phase transition, that means the solidification. Third one will be the solid state. Now the question is the volume of metal which will be compensated from the riser. The volume of metal which will be compensated from the riser. How much volume it will compensated by the riser? The two shrinkages that are basically compensated by the riser. So what is the volume? 3% for the liquid plus 4% for the phase transition or the solidification. The total volume it can compensate, that is nothing but the 7%. The riser is only responsible for compensating the first two type of shrinkage. One is the liquid state shrinkage and second is the phase transition. But for this third shrinkage, from the melting temperature to the room temperature, you are providing the extra dimension to the pattern. So for this particular question, the correct answer will be 7%, because I am talking about the riser only. Suppose if the question is related by the volume of metal compensated by the allowances, then what will be the correct answer? Or what we call the allowances, what will be the correct answer? Only 5%, because during the 5% you are providing the allowances on patterns, and this volume will be compensated by providing the allowances on pattern during this third stage of shrinkage, which is called as a solid shrinkage. Okay, but if I'm talking about the riser, only first two shrinkages will be compensated, which is 3% and the 4%. Now, one more very important question I will say. Why this is important? Because this question is the match the column question, But sometimes the gate is framing the question and they are taking one option, or they are framing, let us suppose, what is metallic chills, and then they will frame the 4 options. Okay, that means this question, if I will tell, this question is not a single question, this is the 4 question. So you have to understood what is the different the parameter which is mentioned in the column 1. The first one is the metallic chills. What do you mean by metallic chaplet? What is riser? Riser you already know, which is basically a reservoir of molten metal. So this is over. And the S is nothing but the exothermic padding. Okay, so you have to correctly match these PQRS option with the 1, 2, 3, 4. But let's try to understood one by one what is metallic chill, metallic chaplet, riser, as well as exothermic. Okay, because MCQ question can be framed from these 4 options. That's why I have taken this problem. This question was asked in the GATE 2009. Okay, so what do you mean by, first of all, metallic chill and chaplet? To understand this, first of all, you understood what do we mean by core. Okay, just 1 second. We take one slide. Okay, so what do you mean by core first? So core is basically used to make the hollow cavity. It is used for making hollow cavity. Hollow cavity. That means cylindrical pipes. If you want to make a pipe, you can use the core, because you know that the pipe means having some thickness. To make the hollow cavity, we are using the core. So let me draw first the diagram. Okay, so this is basically a casting. Now this is the core which I have placed at the center. Why I am placing the core here? Because I want to make a hollow cavity. So this is basically a core. This is basically a core. So the liquid molten metal can enter here as well as here, but it should not enter at this particular position. That's why I'm using as a core, so that around this, the sand mold will be there. Okay, from the gating element, the liquid molten will enter, and this is after the solidification. What will happen? The sand mold can be broken. You will get this product, and this core you can taken out. If you take out from this one, then you will get the hollow cavity. So core is basically used for making hollow cavity. Now, if you are pouring the liquid molten metal here, what will happen? This core will get displaced. Yes or no? For supporting this core, we are using the core print and the chaplets. Now, where you will use the core print and the chaplet, now understood. This is basically the core print. This is basically the core print. That means if you want to support this basically core at these end point, then you can use the core print. So core print are basically used to support the core. What do you mean by core print? The core print it is used it is used to support the core. It is used to support cores and hold them in a proper position. Proper position. Okay. Now, sometimes the core cannot be passed throughout this section. That means if the core is not passing through the entire casting, then you will use the chaplet. For example, let us suppose the core will be in this shape. If the core will be like this end is not reaches here, that means the complete core, whatever you are taking, it's not passes through the entire casting. So how you will support this particular core? Then you will use the chaplet. What are the chaplet? Chaplet are nothing but it's a holder kind of thing, which is a metallic, made up of some metals. This is called as a chaplet. With the help of this chaplet, you can support this core. Now, the third key point I'm going to discuss, which is called as a chaplets. What is chaplet? If core do not passes through the entire casting, it can be supported by chaplet. It can be supported by the chaplet. That means if the core do not passes through the entire casting, then you will use the chaplet, and during that time, it will support the core. Okay. Now the next thing is, what do you mean by riser? Riser I have already discussed, so I don't want to spend more time over there. So what is riser? Riser you already know, it is a reservoir of liquid molten metal. Reservoir of liquid molten metal, which will supply during the solidification. Okay. Now the next thing is, what do you mean by chills? Chills are basically, these are the metallic object. These are metallic object which is used to increase the rate of solidification. Rate of the solidification in some specific area. What it means? For example, let us suppose the core will be at this kind of cross section. Okay. So from here, because this is basically a mold cavity, that means here will be a sand particle. So through the sand particle, the heat can easily release. But at this cross section, this particular portion is not exposed to the atmosphere. So more amount of heat cannot be released. So what you will do, you will use the chills at this particular point, so that the rate of solidification, that means the amount of heat which will be released at a faster rate, so that you will get the uniform solidification. Why? Because if you will not use the chill, then what will happen? It will solidify from here, all the liquid molten will solidify, but here it will be not solidify. That's why we are using the chills. Chills are nothing but these are the metallic object which is used to increase the rate of solidification in some particular area. Same thing, in sometimes you will use the padding also, which is called as the exothermic padding. So the next one is the exothermic padding. So exothermic padding means this basically controlling the cooling of critical cross section. So for example, let us suppose you have made this as a casting product. Okay. Now you know that this is basically a three-dimensional object. So from here, the heat can be released very fastly. But at this point, and this point, the cooling is not proper. Okay, that means the rate of heat transfer is not proper. Then what you will do? You will use the exothermic padding. That means you will use the material, so it will control the cooling of this particular cross section. So it will increase the rate of heat transfer. So you will add padding here, which will increase the rate of heat transfer from this corner point, because at the corner point the area is very less, the exposed area is very less. If the area is more, then the rate of heat transfer will be more only, no? Because you know that the rate of heat transfer through a convection is HA delta T. When the surface area is more, the the heat will transfer at a faster rate. But the area is not proper, that means it is not exposed to the atmosphere. What you will do, you will use the exothermic padding. Now, this whole theory which I have discussed till now, based on that, they have framed one question in the form of match the call. But again, I'm telling you, this question not a single question, because this riser part they have already asked 2 times in the gate exam. Maybe in 2025, that means in this year, they can frame the question based on metallic chills or the chaplet, and they will frame the 4 option. If you know the concept, you can easily mark the correct answer. So what is the metallic chill? Metallic chill is basically used for progressive solidification or directional solidification. What I mentioned, these are the metallic objects which will increase the rate of solidification in a specific area. That means whenever there is a directional solidification is required, that means in which direction you want to directional solidification. Suppose the heat is transferring from this cross section in this way, but the less heat is transferring from this point, then what you will do, you will add the chills at this particular point, and then again the heat transfer will be taking place. That means the heat transfer, if you want to do in a directional way, that means if you are giving the direction at that particular point, you will use the chills. That is also called as a progressive solidification. So for metallic chills, the correct answer for P is 4. What about Q? Metallic chaplet. Chaplets are basically used to support the core. Yes. Maybe they can give you the one more option as a what we called as a core print. Core print is also used to support the core. I have discussed now, no? The core print is used to support the core when it is when the core will be passing through the entire casting. If it is not passing through entire casting, then you will use the chaplet. So chaplets are basically used to support the core. So Q is 1. Then riser you already know. What is the answer for riser? Riser is nothing but the reservoir of molten metal, and S is nothing but controlling the cooling of critical cross section. So to increase the rate of heat transfer, then you will use the padding also. Okay, so the correct answer for this question is choice C. One more trick I want to give you for whenever the question will come related to the match the column. What you will do, try to find out which option you know. No need to read all those parts. Why I'm telling you, see, if you see the all these 4 options, if you know about the metallic chills, what do you mean by metallic chills, which is producing the progressive solidification? Leave it. Suppose if you know what do you mean by metallic chaplet. Chaplet is used to support the core. That means Q related to first. You can check only one option is there. This will help you for solving the question in a Q. Okay. So whatever the options which you know, just try to match those part, and remaining you can easily eliminate by seeing the options. Okay, so for the correct answer for this question is choice D only. And this is very, very important because more than 4 to 5 concepts I have covered in the single match the column question. Now, one more question. In gating system, the ratio of 1:2:4. You know that what is the gating system? Gating system. I have already discussed this part, but still I'm explaining you. This is the runner. This is basically a complete gating system. Okay, this is the riser. What do you mean by this? This is basically a pour-in basin. This is a sprue. Okay, this is called as a horizontal runner. This is the in-gate from which the liquid molten metal is entering. This is called as a riser. Okay, so the in gating system, the ratio 1:2:4. That means what is the ratio is indicating? You always remember the gating ratio. In gating system, the ratio means the gating ratio. The gating ratio is nothing but the ratio of what is this? Sprue. This one is a runner, and this one is in-gate. If you take the ratio of these area, which is called as a gating ratio. So area of sprue, the next one will be the area of runner, and the next one will be the area of in-gate. Sorry, this will be a area of in-gate. So the correct answer for this question is choice A. And this question was asked in the GATE 2010. Very, very simple question. Because if you know how the gating system is designed, what is this one is pour-in basin, this is sprue, this is horizontal runner, in-gate, this is the mold cavity, this is the riser. And here is also you are providing some splash core just to support this mold cavity. So the ratio of area of the sprue, runner and the ingate, which is called as the gating ratio. So please make a note of this. Now the next question. Now the next question is related to the solidification only. Cubical casting of 50 side which undergoes volumetric solidification shrinkage and the solid contraction. Okay, so it is given that, because I have already discussed, there are the three type of shrinkage. This is called as a liquid shrinkage, solidification shrinkage, and this portion is called as a solid shrinkage. Okay, so what is the question? A cubical casting, that means a casting having a cube size, cubical shape, and the size of the cube is given as 50 side, which undergo solidification, whose percentage of shrinkage is given as 4 and 6%. This 4% is belonging to the solidification shrinkage, means this case, and solid contraction means solid shrinkage is given as 6%. No riser is used. Okay, because if the riser is used, you can easily compensate this shrinkage, which is called as a solidification. But it is given that no riser is used, assuming uniform cooling in all the direction. Okay, the side of cube after the solidification and the contraction you have to calculate. Okay, now how you will solve this particular problem? You know the volume of cube is nothing but a cube. I hope now there is no lag while I'm writing, because I have switched off that camera, because maybe because of the internet connection, sometimes it's getting stopped. Okay, so the volume is equal to a cube. So let us suppose I am taking a as the side of cube. Side of cube means, let us suppose this is the cube whose side is this one. Now the side of cube after the solidification shrinkage, solidification, because there are the two types of shrinkage they have mentioned. One is the solidification shrinkage, this one. Another will be the solid contraction, and it is given as 4 and 6%. Okay, now this is 4% is shrinkage. 4% is shrinkage means, can I write the dimension of, or the volume is nothing but, I am just denoting with A1. A1 is nothing but the solidification after the first stage. What is the volume? A1 cube is equal to 0.96 times of 50 to the power of cube. Why I have written? Now see, 4% shrinkage is happening. That means whatever the volume you have initially, what is the 4% shrinkage means? Now it will be multiplied with the 0.96. If it is a 10% shrinkage, then it will become 0.9. 0.9 times of the original volume is nothing but the volume after the first shrinkage. Okay, so A1 cube is equal to this one. So from here I can calculate the value of A1 is nothing but 0.96 cube root, and this cube root, if you will take, this will become 50. What I have done, I'm just taking this 3 to the power of 1 by 3. So this will become cube root, and this will become 50. So after the first solidification, then A1 value is 49.32 mm. 49.32 mm. Okay, so this is the side of cube after the first solidification. Now again the solidification is happening. What is the second solidification? The volumetric solid contraction is given as 6%. That means whatever the volume which you got, whatever the volume or whatever the side which you got, now again it is contracting by 6%. If it is contracting by 6% means, what will be the volume left? So the side of cube, if I want to calculate after the solidification, after the solid contraction, which will be the second stage, which is nothing but AF final. Now I am calculating the final. This is the volume, which will be equal to 0.94. Why I have taken 94? Because 6% is shrinkage. So 0.94 times of A1 to the power of Q. Because initially, let us suppose this is the V0 volume. First shrinkage is happening. Now you reach as a V1, then again second stage shrinkage, then you reached as a V2 or V final. Okay. So how you will get the V1 value? A1 to the power of Q. This because it is given that the volumetric shrinkage is 0.96 times of original volume. So from here you can easily calculate what will be the dimension after first shrinkage. That shrinkage volume will act as the original volume. Then second stage shrinkage is 6%, which is nothing but 0.94. 0.94, that means AF final I can calculate 0.94 cube root into A1 value 49.32. 49.32. So if you solve, then you will get 48.32 mm. Now the choice A will be the correct answer. Choice A will be the correct answer. Okay. So there are the two shrinkages which is given, 4% and shrink 6%. Initially you have a volume V0. Now after this 4% shrinkage you got as a V1. Then again shrinkage is happening 6%. Then you are getting as a V2. First you have calculated the dimension corresponding to V1, which is nothing but the 4% shrinkage means 0.96 times of original volume. Then you will get the A1 value, first shrinkage. Then you will take this A1 value as a standard, which is the original volume now. Now again it is contracting. How much contraction is 6%? So 0.94 if you will solve, then you will get the 48.32. Very simple question. If you read the question carefully, then you can easily solve. 4% is 6% shrinkage is given, 0.96 and there will be 0.94. Now, one more question was asked in the GATE 2013, which is related to the solidification time. That's why I have told you in the casting, three types of problem are important. The first one is the question will come from the defect. The second type of problem they can make, how much time is required to filling the mold cavity from top gate system and the bottom gate system. And the third one, the design of riser. Third one is design of riser. Design of riser, I can, in the design of riser means how much solidification time is required. Okay. Now the question based on the third one, which is nothing but a cube shaped casting solidify in the 5 minutes. Okay, one cube is there which is solidifying in the 5 minutes. So the solidification time is given as case number 1, which is cube only, which is given as 5 minutes. So one cube is there which is solidifying after 5 minutes. The solidification time in minute you have to calculate of a cube for a cube of the same material. That means the material which you are using for casting, that is same only, which is 8 times heavier than the original casting. Okay. So first I have assumed this is the case number 1. The solidification time is 5 minutes. But before that, what is the solidification time formula? Based on that, I have already discussed one problem. The solidification time is nothing but K into V by A whole square. Okay. This is the solidification time. This is the solidification time constant. V is the volume of the casting and A is the surface area. Now, the solidification time you have to calculate for the cube, which is 8 times heavier. 8 times heavier means their mass will be 8 times heavier because the material is same, means density will be same. Okay. So can I calculate what is the V by A ratio first of all? So that I will directly use V by A is nothing but what is the volume of cube? A cube. Surface area is 6A square. What is this value? A by 6 only. A by 6. Now can I write this T1 by T2? What is this T2? T1 is related to the first case. If you are using an original cube, which is given in the question. Now the second case is 8 times heavier than the original casting. So this is the original casting. Now the second case, the mass of second casting is 8 times heavier. So let us suppose in case number 1, the mass is M1 is ρ1 into V1, density into volume. Case 2, the mass 2 will be ρ2 into V2. And it is given that M2 is 8 times of M1. You know that the density will be same because you are using the same material. If you equate this, what it is given, M2 is equal to 8 times of M1. 8 times heavier than the original casting. So that means V2 is equal to 8 times of V1. Can I write A2 is equal to 2 times of A1? How? Because V2 is nothing but A2 cube. Volume of cube is A2 cube. V1 is A1 cube. A1 cube. So if you take the cube root of 8, you will get the 2. So A2 can be written as 2A1. Now the solidification time can be written as the ratio of solidification time. If you take the first case and second case solidification time, so the K value is constant. Okay, then V by A ratio you are getting as A by 6. So can I write this? A1 by 6 divided by A2 by 6 whole square. I can directly write the 6 will cancel out, A1 by A2 only, just for factor of safety. Now, one more thing, V by A ratio, T1 by T2 you are getting as A1 by A2. So can I write T2 by T1 is equal to A2 by A1, A2 by A1 square. Why? Because you want to calculate the solidification time of second cube. So T2 can be written as A2 by A1. What is this A2 by A1? A2 by A1 is 2 only. So this will become 4 times of T1. What is the solidification time for first one? 4 into 5, which is 20 minutes. 4 into 5, which is 20 minutes. Again, I'm repeating the question. A cube shape casting, that means a cube is there. Casting shape is the cube. So its solidification time is given as a 5 minutes. The solidification time in minute for a cube, when the same cube, if you are taking, which is 8 times heavier. Okay, 8 times heavier means M2 is equal to 8 M1. You know that the material means same means density will be same only. So the volume can be written as 8 times of V1. Because the density will cancel out. So V2 can be written as 8 V1. So from here you can calculate the dimension of second cube, or we can say that the second case is coming out to be 2A1, and the solidification time is nothing but K into V by A to the power of whole square. So solidification time is directly proportional to A by 6 whole square. So if you take T1 by T2, you will get A1 by A2 whole square. So T2 by T1 is equal to A2 by A1. So you know the T1 value, and this value you got from this one. So 4 times of T1 you are getting as the solidification time is 20 minutes. Okay, so for this question, the correct answer will be choice B. I hope you understood. So that means that they can frame the question in different formats. But if you see the same concept I am using, which I have discussed earlier, solidification time formula will be the same. Sometimes they will give you the sphere. That means you have to consider the volume of a sphere as well as the surface area of a sphere. That means they are changing the geometry, but the question will be, or the concept will be same only. One more question, a very good question I will tell you. Okay, actually this is basically based on the some important theory. What is the question? Because these are the standard results. If you remember, then you can easily mark the answer and you can move to the next question. But I will discuss the complete derivation. A cylindrical blind riser with the diameter is d, that means the riser is given whose diameter is d and the height is h, which is placed on the top of mold cavity. Okay, if the riser is of constant volume, it is given that the riser is having a constant volume. The rate of solidification of riser you have to calculate. The rate of solidification, it is mentioned that in the riser is least. That means the solidification time, the rate of solidification means the least solidification time. Solidification time will be least. What will be the ratio of h by d? What is the h? H is the height of the riser and d is the diameter of riser. Okay. So first of all, you have to understood what do we mean by, one second. The rate of solidification means rate of solidification least means solidification time
solidification time will be, you know that the solidification time formula K into V by A whole square. Now you see, it is given that the volume of, just 1 second, yeah, the volume is constant. The volume is constant. That means only the solidification time is related to the area. Okay, so if area is minimum, can I say the solidification time will be maximum? Yes or no? Solidification time will be maximum when the area is minimum. That means you have to do, if you understood this important thing, your problem will be solved. Solidification time more means you need more time, more solidification time. The area should be minimum. Surface area should be minimum. Surface area should be minimum. So what is the surface area? Pi dh plus pi d square by 4. Because you know that if it is a cylindrical surface, the surface area is pi dh. Okay. And for the top riser, you can see here is placed on the top of mold cavity, and the riser, then the rate of solidification in the riser is least. You have to calculate this h by d ratio. Okay. Now, what is the area? Surface area is pi dh, and the surface area, this area will be the pi d square by 4. So this is for the top riser. Very important for top riser. Let us suppose if it is a bottom riser, this is for the top riser. That means you are providing the riser from here or for a top gate system. Now you want to surface area minimize. You know the volume is pi by 4 d square into h, the volume of cylindrical surface. Can I write h is equal to 4v by pi d square? Then if I will put this h value in the surface area equation, let us suppose this is first. So pi d into 4v, this is pi d square plus pi d square by 4. Okay, so this value will be cancelled out. Then you will get 4v by d plus pi d square by 4. Okay, so why I have converted this h value in the terms of d? Because you have to minimize the surface area. Minimizing the surface area means if you want to minimize the function, let us suppose if fx is given as 3x square plus 2xy. What you will do minimization means you will differentiate this function with respect to x or with respect to y. Let us suppose 3x square plus 2x. If this is the function, if you want to minimize, so you will differentiate with respect to x and you will equate to 0. So same thing I have done, because there are the two unknown. I have converted h in terms of d. Now I will differentiate this area in terms of d. So partial differentiation of a with respect to d equal to 0 if I will do. Let me add one more slide. What is the differentiation of this one? 4b by d. 4b is a constant. 1 by d differentiation is minus 1 by d square. So 4b by d square plus pi d square by 4. Pi d square by 4 means this is 2 pi d. Pi d, d square differentiation is 2d. So 2 pi d by 4 is equal to 0. So from here, so 4b by d square can be written as 2 pi d by 4. That means the d cube can be written as 8v by pi. Okay. And what is the volume? Volume is nothing but, you know, the volume is pi by 4 d square into h. Pi by 4 d square into h. Okay, so this square and this power will be cancelled out. So this will become d. And I'm just taking this h in the denominator. So d by h, because I have to calculate d by h ratio. Sorry, h by d ratio. So I will do one thing. First of all, I will calculate the d by h. So d by h is nothing but 2. So what is the h by d ratio? H by d ratio is 1 by. Always remember this important standard result. Okay, this I have discussed in my live class also. But how this result came, if you read the question carefully, the rate of solidification you want to minimize, that means it should be least. That means rate of solidification means the solidification time will be more. Solidification time will be more means the area should be, surface area should be minimum. So you know the area value. Area is pi dh pi by 4 d square. You have minimized this area to get the solidification time more. Then you got the ratio of d by h, or sorry, h by d is the 1 by 2. So what is the correct answer? A will be the correct answer for this question. Choice A is the correct answer. Choice A will be the correct answer. Okay. So we have more 20 minutes. So I will discuss some of the other problems. Okay. So can you please try this problem? Otherwise, I will discuss the same. The question, it is based on the same format, but it's basically we are using the one is the cube. Top face of one of the cube is completely insulated. Okay. So in one case, I am just one surface will be insulated and another is not insulated. What is the question? A solidification time of casting which is proportional. Always remember in this particular question, in GATE 2015, they have given the formula also, but it's not necessary. They will give you the formula. But you already know the solidification time is proportional to V by A whole square. If you remove this proportionality, you can introduce one constant which is called as a solidification constant. So K into V by A whole square. Okay. Now, what is the question? V is the volume, A is the area, surface, casting surface area, which is losing heat. 2 cube of same material. Okay. Again, they have taken the 2 cube, which is having the same material and the same size. Size is also same. That means the cube size in the first case and second case, I can assume as a A. A is the dimension of cube. Top face of one of the cube is completely insulated. Okay. Then what is the thing? This is the cube. In one case, so I'm denoting with the green color. Green color means this surface is insulated. What do you mean by insulation? Insulation means the heat transfer will not occur from this top surface. Only the 5 surfaces are responsible, because you know that in cube there are the 6 faces. Okay, so one surface, if I have insulated, so only the heat is transferring from the other surfaces. Okay. Now, if heat is transferred from other surfaces, so how many surfaces are playing a role? In this case, 5 only. So what is the surface area? So this is basically the first case in which there all the surfaces are participating for heat transfer. Now in the second case, if one of the face is insulated, so this is one is insulated, I'm representing insulated. Okay. So here the 6 surfaces are responsible for transfer the heat. Here will be only 5 surfaces. 5 surfaces. Okay. So let us suppose this is the case number 1. This is case number 2. What you have to calculate the ratio of time taken, or the ratio of the solidification time for the cube with top face insulated to the other cube. Okay. So always remember, sorry, always read the question carefully. They were asking the ratio of solidification time for the cube with the top faces insulated. That means they were asking what is the solidification time of 2 to the solidification time of 1. What is the solidification time of 2? The solidification time of 2 is nothing but, you know that the volume is same. Can I write? Because it is inversely proportional to area, can I write this is A1 by A2 whole square? Very simple, because if you want, you can write this way also. K V1. So volume is constant, so V by A1 whole square. T2 K V by A2 whole square. So the T2 by T1, can I write A1 by A2, because the volume is constant? That means the volume is same only. So T2 by T1, I can write 1 by A2 whole square divided by 1 by A1 whole square. So the A1 square will become in the numerator, or you can easily see volume is constant, T is inversely proportional area. So if 2 is coming here, the area will become. Okay, so A1 by A2. What is the A1 value? What is the A1 value? So A1 value is nothing but the 6 surfaces are involving. 6 surfaces are involving means 6a square will be the surface area. Here will be the 5a square. And what is this value? A square will cancel out. 36 by 25. I hope you understood this problem. Very simple problem. The only thing you have to understood the language of this question. One of the surface is insulated, that means it is not taking the part for the heat transfer. So only 5 surfaces are there. So what is the surface area? 5a square. In the first case, only all the 6 faces are responsible for the heat transfer. So 6a square. So 6 by 5 whole square will be 36 by 25. The B will be the correct answer. B will be the correct answer. Okay. So till now, what I have discussed, the question based on the defect. Second thing is, what are the important terminology related to the gating system? Third one is, how you will calculate the solidification time, the time for filling the mold cavity by top gate system and bottom gate system, and how you will calculate the solidification time. Now, the next one is how you will design the riser. Okay, let me take that problem also. A cylindrical jaw with the diameter is 200 mm, height is given as 100 mm, is to be cast using modulus method of riser design. Okay, so there are various method of riser design. So the modulus method, the modulus of riser is 1.2 times of modulus of casting. Okay, what is modulus? Modulus is nothing but volume by area ratio. Volume by area ratio. Okay, you have to calculate what will be the diameter of riser. Sorry, what will be the height of riser? It is given that the diameter and height are equal. That means the diameter is not given, height is also not given, but the condition is given, the diameter and the height are equal. The casting size is also given, which is in the cylindrical jaw. That means, suppose modulus of riser is 1.2 times of casting. What I will do, first of all, I will calculate the modulus of riser. What is modulus of riser? Modulus of riser is volume by area ratio of riser. What is the volume of riser? Riser in the cylindrical shape, pi by 4 d square into h. What is the surface area? Pi by 4 d square plus pi d h. Now, one more thing. This is basically a cylindrical riser, means the riser will be like this. Okay, the heat transfer is taking place from the circumferential as well as the top and bottom. What is the area of circumference? Pi dh. The top area is pi by 4 d square. Bottom area is also pi by 4 d square. If nothing is mentioned, you have to consider this. But if you read the question carefully, it has given, assuming that the bottom surface of cylindrical riser does not contributing as a cooling surface. That means this time they have framed in form of cylinder. If you see the previous question, they have given in the cubical form. That means this bottom surface is not taking part of heat transfer. So how many areas are there? Pi dh, pi by 4 ds. That means this circumferential area and this area. This is not taking part. If it is nothing is mentioned, then you have to multiply with 2. Okay. So only one what we call the top area is taking place for the heat transfer. Then you have to consider that one only. So the diameter of riser is equal to height. So d is equal to h. If d is equal to h, can I write modulus of riser is equal to pi by 4 d square, and h is equal to d, means this will become d, pi by 4 d square, pi d square. What is the modulus of riser? Pi by 4 d cube divided by, this is pi d square, sorry, this is pi d square by 4. If you take the LCM, this will become 4. So 4 plus 1 is 5. So I can write 5 pi d square by 4. Okay. So what is this value? This value is nothing but d by 5. Yes or no? This pi value will cancel out. This d square will become d, and this 4 will also cancel out. So you will get as a d by 5. So modulus of riser you are getting as a d by 5, where 5 is nothing but it is an integer. So modulus of riser you are getting as a, modulus of riser is equal to 1.2 times of modulus of casting. Modulus of riser is d by 5 is equal to 1.2 times of modulus of casting. What is modulus of casting? You can easily calculate, because The diameter is given, height is also given. Now I will calculate the modulus of casting. Modulus of casting means, modulus of casting is volume by area ratio of casting. What is volume of casting? Pi by 4 d square into h. Now, in case of casting, you have to consider both the area, because the riser is basically one surface is insulated. So now it will become 2 into pi by 4 d square plus pi d into h. Okay. So this is basically casting. Casting is basically a cylindrical job. Only the riser having a one surface is insulated. So what is the diameter value? Let me take the diameter value as a 200 mm, and height is given as 100 mm. Height is given as 100 mm. Okay. So diameter is 200 and height is 100. So d by 5 is equal to 1.2. So pi by 4. What is the d square? 200 square into 100. This will become pi by 2 d square. D square value is 200 square plus pi 200 into 100. Now the d value, if you solve, then you will get 6 into, or I will write directly the answer. If you solve this, then you will get diameter is 150 mm. Okay. Now the question is, what they were asking, the height of riser, but you got the diameter. But one more condition they have given, if the diameter of riser is equal to height, because you have taken d is equal to h, no? So that means the height value is also equal to 150 mm, because it is how this result you got, because you have assumed the diameter is equal to height. You have calculated one parameter d and you know that d is equal to h. So the correct answer for h is nothing but 150. So the choice A is the correct answer. Choice A is the correct answer. Okay. Now this question based on the riser design. You have to use this particular formula. Now one more question related to the casting, but it's a very good question because they have given the gray cast iron as a casting size, as well as there is a spherical cavity. What is happening? One block is there. At the center of block, one spherical cavity is there. Okay. You know that whenever there is a solidification, what will happen? The size will contract. For example, if you are taking as a cube of size is 30 mm. Under the solidification, what will happen? The size will get reduced, means all the dimensions are reducing. Now you will get the actual shape of cube will be 29.8 or something. Okay. I don't know, it may be 29.8, 29.6, but the size will get reduced. That's why what you are doing, you are using a pattern of larger size. To making any casting object, you are using the pattern of larger size, means you will take as a 30.2, because after the solidification, it will reach to the desired casted product. Okay. So the based on that concept, this question was asked in GATE 2016, gray cast iron block of size. Okay, so let us suppose this is the gray cast iron block having this dimension is 100, this is 50, and this dimension is given as 10. And inside there is a spherical cavity. So I'm just denoting with like this. What is the diameter of spherical casting? That is 4 mm. You have to calculate what is the volume of pattern to the volume of casting. Okay, that means Vp value divided by Vc you have to calculate. How you will do? Volume of pattern is nothing but, you can easily calculate. The shrinkages allowance is 3%. That means 3% shrinkages is each dimension. This one is also shrinking 3%. This is also. Okay. So for pattern, what you will do? You will add the 3% shrinkage. So volume of pattern is, what is the volume of pattern? The volume of this one minus volume of spherical cavity, because this is the cavity. So if I want to write down for volume of casting, can I write 100 into 50 into 10? This is the volume of this block minus this cavity, minus this cavity 4 by 3 pi r cube. What is r cube? Diameter is 4. This one. Because you know that the volume of this gray cast iron block will be this complete block minus the spherical cavity. Now 3% shrinkage is in each and every dimension, means the volume of pattern should be more or the dimension should be more. So what I will do, I will add this 3% in each dimension. So what will become 100 into 1.03? Yes or no? 3% shrinkage means you have to add 3%. So if you are adding 3%, so 3 by 100, what you will get? 1.03 only. So 3% means now this dimension will become 100 into 1.03 into 1.03 into 50 into 1.03 into 10 minus 4 by 3 pi. Radius is given as 2. So again 3% is 1.03 times of 2 square. So volume of pattern by volume of casting, if you will solve, you will get 1.09. And this is the answer. In this question, nothing is there. The only thing you have to see, the 3% shrinkage is there. That means the 3%, this dimension will become 3%. That means 97. This 3%, this 3%. Okay. So if it is shrinking, then what you will do? You have to oversize the pattern. Why? Because even after the shrinkage is happening, then it will reach to the original casting product or the desired casting object. Okay. So the correct answer for this question is 1.09. We can solve this calculation. If you do the calculation, you will get the 1.09 as an answer. Okay, one more question, the last question I want to discuss before ending this session. And I will suggest you read the question and try to solve. This question is basically related to the what you have to calculate the velocity of molten metal at the bottom of a screw. Same type of question I have discussed. Try to solve this problem. Okay, I will explain the problem. A screw in a sand mold has a top diameter of 20 mm and height is 200 mm. Okay, you know what is a screw. If you don't know the screw, then you can't solve the problem, because all the gating element which I have discussed more than 3 times. This is the pour-in basin. This is basically a screw. Now let us suppose this I'm assuming as a 1 point. This is 2 point. This will be the 3 point. This is, let us suppose, height of a screw, and this height I'm assuming as a pour-in basin. Pour-in basin HP. This is the total height. Let us suppose this HT is nothing but HP plus HS. Yes or no? Now the velocity at 2 point. What is the velocity at 2 point? The velocity at 2 point, can I write root 2 GH? Because you know that whatever the potential energy is there, that will be converted into kinetic energy. Okay, the energy conservation. So the potential energy at this point is converting into the kinetic energy. So mgh is equal to half mv square. Very simple mechanics. So this mm will cancel out. You will get v is equal to root 2 gh. So v2 is equal to root 2 gh2. So instead of s2, I am assuming as a p, because at this particular height is nothing but hp only, height of pour-in basin. So v2 value you can easily calculate. What is the g value? 9.81. Okay, again most of the students do the mistake here. If nothing is mentioned, you have to assume 9.81. For example, if acceleration due to the gravity, if they are giving as a 10, you have to assume the 10 value. Otherwise, once you will solve, you will get the answer, and if you will put that particular answer, you will get the 0 marks, because you don't know what is the correct answer, because this is a numerical answer type question. Okay, so whatever the data is given, you have to consider that one. So G value is 9.81. H value, that is the height of pour-in basin. What is the height? The height is given or not? Okay, height is not given, but the velocity of the molten metal at the entry of a sprue, this is given. That means when the molten metal is entering into the sprue, the velocity at the 2 point is given. Okay, so velocity is given as 0.5. So if you take the square, then it will become 2 into 9.81 into HP. So this HP value is nothing but 0.01274 meter. Okay, so what is the HT value? Height of the pour-in basin is already given 0.2. Height of the pour-in basin, which is already given 0.2. Where it is given? You already calculated this 0.2 is this one, height of this screw. Height of pour-in basin you have calculated as 0.012, 0.01274. So what you are getting 0.21274. That means you calculated as the total height. Once you know the total height, again same formula if you use, you will get the velocity at 3 point. What is the velocity at 3 point? The velocity at 3 point is root 2g. Can I write into ht? Because at this point the velocity is root 2g ht. At this point the velocity is root 2g hp. At this point the velocity will be 0. Why? Because there is no height. Now the v3 value, if you solve, then you will get 2g is 9.81. What is the ht value? The ht value 0.21274. One more thing I want to mention here. All the dimensions are given in mm. So if you consider this is a mm value, okay, but you are taking g value as a meter per second. Okay, so most of the student will do the mistake here. What they will do, they will equate this velocity with this one. For example, if hp value you are getting as a this one, okay, or if you are getting as a mm value, if you put here, then you will get the wrong answer. Either you convert this g value in the meter per second, which is already given, that means h in meter per second. If you are taking h value in millimeter, so you have to convert g into millimeter. That means 9810, 9810. Then you will get the answer. Okay, so please don't do the mistake here, because the possibility of mistake in this particular question is the unit conversion only, because the remaining question is very simple. Okay, so if you calculate this value, you will get as a 2.043 second. 0.43 second. One more thing I want to mention here. Sometimes in